Hello, friends. Welcome back to Creative Exploration with Pers. Today, I want to go over a workflow just thought of this morning, kind of. It's been brewing the last couple of days, but the idea being we can create looping idle animations with AnimateDiff and basically use those animations to like puppet new stuff on top with LivePortrait. So, you get these sort of these cool animations where the person's just hanging out, and then we can take control of them. So basically, I figured I'd start by just building this workflow out sort of from scratch. You guys can see how it all works, and then after we got it working, then we'll start puppeting them with LivePortrait, and then you'll be able to basically make, somewhat consistent characters. Oh, looks like my webcam was wigging out there for a second. Hope that doesn't keep happening. Oh, strange. All right. Let me know if there's any problems with the stream or whatever. Yeah, that was weird. All right. So basically, this workflow takes an IP adapter image, runs it through the new Clip Vision Enhancer IP adapter node, and does some prompt extraction with Florence and Clip Interrogator. Makes a prompt, sends that into the positive. We send a negative prompt through, and we just make a nice little IP adapter with prompt reinforcement thing that we can just plug in images and make little animations from. You can determine then the length of your animation. You can determine whatever you like. So we're going to stick with realistic stuff for today because I don't know how well it works with anime. You have to do that testing on your own. I got it to work with like puppets, but if it doesn't detect a human face when we get to the live portrait section, it's not going to work. So I'm just going to try and get the faces somewhat realistic today so that live portrait will work. And then, you can take this workflow and start messing with it at home and try to get anime characters if you want. Should be possible though. I think it'll work. You just need to try it. All right. So let's save this, and then let's delete everything and start over. All right. You guys too. Get the hell out of here. What the hell? All right, there we go. All right, let's go. So what do we want to accomplish? Whoop, pop my mic here, sorry. What do we want to accomplish? We want to use IP adapters and Clip Vision and all that fun stuff to look at an image and then make an animation out of it. So it's a simple image to video workflow using AnimateDiff. All right, so let's start in the middle with the IP adapter clip, the new Clip Vision Enhancer node, so that we can sort of understand how this works. So this node has an input called Enhance Tiles. So you're going to want to switch that to an input. You do that by going down here and saying convert input to widget to input and do it there. That'll make this an input here, and we want to use a primitive integer. I'm using the Chris Tools pack to do my primitives. You can use whatever you like. There's primitive nodes and everything, and there's even ones built into Comfy. I just happen to like these ones, so these are the ones I use. So this is the multiplier at which we are enhancing the tiles for our Clip Vision Enhancer. So Cubic wrote a new node basically that is able to tile the images that we feed into IP adapter to make the limited IP adapter vision model, which looks at stuff at 224 by 224 pixels. Basically make it able to look at multiple tiles and then understand where those tiles are in relation to the original image to increase the fidelity in which we can, get out of IP adapters. So it gives us a big boost to do this. So it's worth learning. So we're going to use a multiplier of 3. So we're going to use 3 tiles. So it'll be 224 times 3. And in order to do that, we're going to use a math expression node, which is in the PyGauss ComfyUI custom nodes or something. If you go to your manager custom nodes folder, that's it. Python Gauss ComfyUI custom scripts. That's where I got the math expression node from. I like it because you can just plug math into it and tell it what you want the math to do. And in this case, we want to multiply A by 224. So that's what we're doing. We're plugging A in, which is our multiplier. And then that's spitting out our new resolution because it's multiplying it by 224. So we're going to use that to power an image scale node. All right. I'm just trying to make these nice and big so everybody can see what I'm doing here. So we're going to change width and height into inputs. And we're going to take the integer from our math expression, which is the number without decimal points, and plug it into both the width and the height. Float is the number with decimal points. Int is the number without decimal points. We're dealing with resolution, which is actually in sort of like groups of 2. So we can't have decimals. So don't worry about floats with this stuff. You can use floats, but as soon as decimals get involved, something's going to crash probably. So it's good to keep that in integer world. So int is integer, float is decimal. All right. And the image is going to be our load image or whatever we use to drive this thing. And we'll just center the crop on it. So we just have to remember that it's going to look at the middle of the image because it's going to tile it out. There are other ways to do this. You can use padding nodes and stuff, but that involves a little bit more finesse with understanding how resolutions work and stuff. So for the ease of use, we're just going to remember that this is always just looking at dead center on our image. But this is the setup basically for the new IP adapter enhanced node. Oh, you guys want splines? Oh, you want splines, do you? Oh, I'll give you splines. There, all the splines you can handle. So yeah, let me rewire this so you guys can see the order of operations here a little better. Yeah, that should make a lot more sense. So the integer goes into both the math expression node to be the multiplier and the enhanced tiles input on the clip vision. And then your load image resolution is determined by the result of that math expression, which is the number of tiles times 224. I'll just leave that up for a minute so you guys can screenshot it and save that. Not a bad idea to save this little workflow as a node template. You just select all the nodes you want to save and then right click away from them and say save selected as template. So you can say like clip IP adapter clip vision enhanced. And then when you want this, you can just node template IP, yeah, just drop it. Save yourself some trouble. All right. I'm going to remove all this stuff around so that it's, less awful. All right, cool. And we are going to use an image of a person. Let's do Ryan Gosling. It won't look like him, and that'll be funny. All right, so let's rename this one too as our tile multiplier. Multiplier? Yeah, multiplier. All right, and 3 is a good starting point. The higher you go, the more fidelity, the more VRAM it'll take as it hits your IP adapter. So that's the Clip Vision Enhanced setup there, and then basically, oh hey Nate, it doesn't work on Mac OS very well. Sorry. You need a NVIDIA RTX card to do this kind of stuff. LivePortrait might work though. I'm not sure. So we're going to use a IP adapter unified loader. And this is what we use to load the IP adapter models that we need. Well, actually, I mean, maybe I should use face. Yeah, we're going to use face. Face is like a better version of the model that's good at doing portraits. And since we're doing human faces, it's a good idea to use it. So let's try it. All right. And the IP adapter comes out into your Clip Vision node, the IP adapter Clip Vision node, and the model goes through that into the next thing. So we kind of started in the middle here, but this is our little IP adapter setup. So we're going to kind of just put that in the middle and start building around it. So we'll make this all, we'll just start by actually colorizing things so that we know what they do. Okay. So we need 3 more things. We need K-sampler, 4 more things. K-sampler, output, and then we need AnimateDiff and all the like settings and global checkpoints and loaders and stuff. All right. So let's build it. We're going to come from the model in, and we're going to build left. We're going to add our AnimateDiff legacy because we don't need the features of V3 for AnimateLCM. We're going to use the AnimateLCM SD15T2V text to video checkpoint. We're going to use it in LCM greater than square root linear mode at a motion scale of 1.15. We're going to turn off the apply models properly. We're going to add out of context options a looped uniform context options. We're going to enable both of these, closed loop and use on equal length. Default settings are fine here. Sample out, sample settings. This one, same deal, except you're just going to leave it at default for now. You can play with this later, but it just exposes this for later use. You don't need it yet, though, so don't sweat it. And we're going to make this light blue because it is AnimateDiff. So that's our little AnimateDiff stack. If you want to add a motion LoRa, you just pop motion LoRa out, add loader, and pick a motion LoRa. Go download them from Civet or, you know, anywhere you get your motion LoRas. Anywhere they sell fine motion LoRas. Blue, and I'm going to bypass this because I'm not using a motion LoRa. All right. Next, we need the settings and the checkpoint stuff. So let's do our clip next. Clip text encode. We need 2 of these. That's going to go in. Well, we don't even have a K-sampler yet, so don't sweat it. This is going to be our positive prompt, green, and our negative prompt, red. All right. And positive prompt will be done by a bunch of cool stuff that we're going to install. So don't sweat it. And we're just going to leave clip on its own right here for now. We're going to add a bunch of nodes below and a bunch of nodes above, but for now, let's keep it simple. We're going to load a checkpoint. This is sort of where you actually start a diffusion process. We're going to use Realism by Stable Yogi LCM version to save time. Model out into a LoRa loader. And we're going to use the V3 adapter. I find it helps with motion. We are also going to add a offset, EPI. I'm going to use the EPI noise offset because I'm not using empty noise with this. I'm going to be using white frames. I'll explain that when I get to the K-sampler. But you don't need this if you're just doing normal stuff, but for what I'm doing, I like it. So EPI noise offset is available on Civetize, EPI_noise offset. You can Google it and grab it. It goes in your LoRa folder. And it's just loaded like any other LoRa. So we've built a little checkpoint and LoRa stack here, and we're just going to pass everything through. So it's like a big water wheel. Model goes to model, model to model, model out, clip, 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 out, right? Bink, 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 bink. So if I were to pass this out, you would see that they're connected as such. Boop, 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 right? They're just chained one after the other. I'm going to make them green because they're loaders. All right. So along with these loaders, we're going to define some global variables. So we're going to use primitive integer. All right. We're going to make a couple of these. We're going to make a width, a height, and a amount of frames. So width, we'll start at, I don't know, 896 by 512. Why not? Primitive integer of 24. Okay, so we are going to do, this is our width, this is our height, and this is our frame count. It's easier to define this stuff in one place and then pull it everywhere you need it, because then when you need to change stuff, you can change it in, that's right, one place. All right. So that's sort of our loader stack. Easy to easy. Clip comes out of the final clip, the load LoRa, into the clip of these two. Model will go into the case sampler once we get there. All right. So yeah, this is actually pretty simple. I'll zoom in here. So if anybody wants to have a quick look and sort of make sure everything's connected before we move forward. Leave that up for a minute. All right. So we've basically got everything we need from the front. Now we need to add the last part where it actually does all the actual work. So let's add a K sampler. And for LCM, we are going to set it to 11 steps, a CFG of 2, actually 1.3. Sampler, I'm going to use the LCM sampler, and the scheduler, I'm going to use SGM uniform. These are the settings. You just start here all the time. All right. So as you can see, this has all the inputs we've been missing. So we need our model from our clip vision enhancer. We need the prompt from our conditioning. Latent image, I'm going to build in a minute. And we're going to actually convert seed to an input. I'm going to use one more node down here called this thurl node. No, the seed node. This is WAS's seed node. There's a million seed nodes. Use whatever seed node you like. You can even use a primitive node if you want. Doesn't matter. All right. We're going to leave the seed as fixed, and I'm just going to put in a random number. And then we're going to make that green as well. And I'm just going to kind of keep myself sane here. All right. And we're going to grab the integer from the seed and plug it into the seed of the K sampler. This will become apparent later why we're doing this, but basically if I can control the seed, I can stop different parts of the run and then enable them later, and it'll continue from that point when I unbypass things. So if we add an upscaler and do some other business, we can disable the upscaler until we find a piece we like, upscale it, then, you know, maintaining the chain and the latents, and yeah, fun. Okay. Normally, you would add an empty latent image for this, but I've been playing with this new thing lately where I'm adding a image blank, which is also in WAS's node suite. And then we just add width and height as variables. And plug in our, you guessed it, width and height. Width, height. So this is going to determine the size of our animation. Now we need to determine the length of our animation. This is going to generate one frame. So we need to repeat image batch. And then this amount is going to be the amount of frames in our animation. So I'm going to change that to an input and plug in our frame count. Bloop. All right. So now this image is a bunch of all white frames, 255, 255, 255. So I've been finding feeding my encoder just straight white frames instead of the noise is getting me more exciting results. So yeah, little tip. I've just been playing with it. I don't know if it's better. It's been fun. So we need a VAE encoder, because now we have to take these from pixel space and put them into latent space. So we're going to grab our VAE from our checkpoint loader. All right. And this latent goes into our latent image. Okay. So we're just going to feed it a series of white frames as long as our animation is, and it's going to diffuse on top of them. So the other thing we need now is a VAE decoder. So we need to take it out of VAE space, and a video combine node. And 24 frames per second. We'll call it idle 24 FPS low res. MP4 13. Yeah, that should be good. And then I'm going to add my little frame interpolation setup here. We're going to grab the output frames from that, and we're going to add a second version. That's slow motion, 2x slow motion interpolated, but it's going to be at a 30 frames per second. And we're going to call that 30 FPS low res. So we'll have two options here. And to do this, we're grabbing the first image from the batch and plugging it into this make image batch with the full animation. So we're doing the full animation, and then we're adding the first frame to the end of it. Then we're film interpolating the whole thing together, and then we're removing the first image, and that gives us a perfect loop when we're doing interpolations. So if you notice your interpolations blip, this is why you need to do this. So that's the workflow there. All right. Let's put this back together because this is messy. Yeah, there we go. Okay. So, can you imagine if we plugged everything in right on the first try? Oh, yes. So we're going to turn on NSFW and nude in the negative prompt because obviously. Okay, now I want to do the prompt engineering. Okay, so we're going to use Florence 2, which I covered a couple things ago, so you probably already have it installed if you've been following along. If not, go install Florence 2. Go check my other video if you don't know how. It's easy. We're going to use the download and load Florence model, and we're going to grab the large model. We are going to do a more detailed caption. Okay, so now we're going to feed our picture of Ryan Gosling, who I'm actually going to grab from, the original image. Sure, why not? Florence doesn't care. And we're going to just have a look at our caption. And this is going to read out a caption for our image. But I actually want to use another type of caption as well. Which is in the Eden node pack. There's the old school clip interrogator. I'm going to turn off blip. Same deal. You go in here. Okay, so we're feeding the image into our two little prompt makers. And we're going to pull our prompt out from here and do another show text. Okay, so these two are going to be strings now. We have these two prompts. We want to stick them together. So we're going to use a string concatenate node. Okay, but we're actually going to use two of them because I want to also be able to add a prefix to our whole thing. So I want to say 4K and then whatever else I want to add, then a comma, and then enter. So then I want B and A and B here to all be inputs. So let's convert these to inputs. Oh, sorry, not A. Okay, let's start that again. B, and then A, and then B. Okay. So it's a little confusing because they go above, but let's try it. We want to concatenate this string after this string into A, this string into B, and then we want to show text here and see what it made. So, yeah. Does that make sense? We are looking at this image. We're taking this caption and this caption. We're putting them together, but we're starting with this. And in fact, we may have to add, didn't occur to me, but we should probably add, you're coming from this concatenator. We need something in between these to add a space and a comma, or otherwise those two words are going to run together, I think. So we're going to make this even more complicated. Add one more string concatenate. B is going to be spacebar. So we're adding one space in B. Okay. So we've got our first string goes into here. Second string goes into here. We need to go into this, add our space. Then we need, oh, hold on. I think I did a stupid. A, B, then the space. Right. And then another string concatenate. It's hard to do the logic in your head, but so after the space, we're going into this out, this to our final string. Okay. Visual programming can be silly sometimes because like this is a lot easier to do it in code, but whatever. The point is now we have a string concatenator that's going to do all the funky business and hopefully give us a really cool little prompt. All right, so once we have that prompt, right, this becomes our positive prompt. So we just switch out our input for the prompt and grab that final long string here, put it in here. And I'm actually just going to take this final string thing that tells us what the whole string is and put it right above the prompt and turn it green so that we can see at a glance what our prompt is going to be. And all this stuff happens down here. And we'll put all this stuff in, I don't know, brown, I guess. And you can be green because you're a loader. I don't know what to call LLM nodes. I don't know what color to make LLM nodes, but whatever. Okay, sampler, you are purple. We're going to do the colors right now before we go crazy. You are cyan. You are red because you're an encoder. Okay, sampler VAE decoder is red. You guys are blue. And I think that's the whole workflow. Should we make Ryan Gosling into an animated character? I feel like this isn't going to work, but it feels like everything's connected. Everything's connected. We run in. Oh. ADE, AnimateDiff. Oh, you know what? You need to plug the model in from the thing. I only missed one connection. That's not too bad. Not too bad. I think I know what I did. So my resolution is too high. So I'm going to get double Gauss. I'm going to get double Gauss here. We don't want double Gauss. We want single Gauss. So because my resolution is above 512 by 512, or more specifically, the aspect ratio is different. We're going to use this node called deep shrink. Deep shrink. Deep shrink. And it just goes, the model goes through it. So grab the model from where it was coming from, plug it in, run it through and out, and then you can just move this stuff back down. This is a diffusion chain, so it's purple. You can leave the settings alone, but it should fix what was just happening where we had the double subjects. So there should be uno gasso now. I mean, I don't know if it's really Ryan Gosling, but I'm just more surprised this actually worked. Yeah. All right. Well, that's a workflow. Oh, forgot to plug the VAE decoder into the load checkpoint node. This is why we fixed the seed, because if the seed wasn't fixed, they would have started that run again. And that would have sucked. All right. I mean, it's kind of Goslish. So this gives us two options. We got one that's like regular, like fastish motion. We got one that's kind of slow motion-y. But because these are loops, right, we can just make a bunch of these and then go use LivePortrait to make them talk and just loop them over and over and over again. Yeah. So to do that, we're just going to add one more video combine at the end here with the slow motion one. I'll plug that in, and I'm going to make one that loops like, I don't know, like 8 times, 12 times. I'm trying to think of how long this should be, about 20 seconds. And I'm going to call that LR long, and we're going to keep those. So these are what I'm going to use to animate on, because it's just going to loop 12 times when it saves. So hit that, it'll save this one. And basically this version, it'll take a little while to save, but if we look at it, it's 20 seconds long. So it gives us lots of time to do the live portrait thing. So we get these sort of like drifting idle animations that we can now use to animate actual performances onto. So the perfect human male specimen. Well, that's nice. What's that make the rest of us? Chopped liver. Should we try, I don't know, RoboCop? I just have a bunch of random photos. Paul Rudd. You think you can do the Rudster? Clip Interrogator knows exactly who he is, too. Handsome Chad Chin. What the hell? Fantastic. We'll just make a few of these and then we'll take it over to LivePortrait and see if we can get them to move around and talk and stuff. Awesome. All right, let's do some tall ones too. So we just swap these 512, 896. Because we're using deep shrink, it should just handle it. And I'll just see what I got here. Let's do. I think I have one of Margot Robbie. Could try her. Yeah, let's try that one. Portrait of Margot Robbie. Neon operator Margot Robbie. Portrait of Sofia Vergara. Pretty Margot Robbie vampire. Rebecca Romaine is Dorothy. Starring Sofia Vergara screaming. All right. This is why I love Clip Interrogator. It's really hallucinating nightmares the whole time. And obviously experiment with the different kinds of, oh, actually we can turn this enhance ratio down to 0.8. There's another node too that is in the default workflow for this, which is also fun to play with, is the image contrast adaptive sharpening node. So it's set up at about 0.5. So that image that comes into your IP adapter, you just pass that through there first. And yeah, we can try and see what it does. Oof. Maybe we'll try a different run. And then if you just change your seed to increment or randomize, it'll do a different, it'll do different seed each run. So when you're doing an iteration like this and you don't care about the fixed seed stuff because your workflow is already running, set it to iterate or randomize. And then every time you run it again, it'll give you a new one. Oh, and if you want to see what this node does, then just grab your image out from the upscaler and grab your image out from here. And actually, there's actually a really cool node for this. It's image compare. compare. Yeah, image compare, I think. So yeah, we plug first one in, second one in. And then this node will let you just go back and forth to see what this change does, which is really sick. Ooh, that's weird that it's pulling in like that. I wonder if that started to happen since I added this contrast node. So let's see what it's doing. Oh, we gotta wait for this film to finish. So yeah, it really brings out the contrast. So that's the original there. And that's the, well, this might not be coming through on YouTube so well, but yeah, so it basically just brings out a whole ton of detail, which actually can be bad for human faces because sometimes it'll add like all kinds of weird scars and pimples and stuff where there aren't any, just because there's too much detail. So yeah, you can set that setting here with how much you want that to add. But if this one sucks too, I'm gonna bypass it and we'll see if it's just literally causing problems. Because like this whole like moving in motion is very strange. But I mean, these are pretty crazy runs. This IP adapter enhanced clip vision node is really, really good. Like that quality is wild for a first run. So now we're interpolating, so it should be a smoother type situation. And then yeah, we got a nice long run of that, so we can. And I mean, obviously, you could super badass upscale these. That's on Bano. Grab that. You know, before you live portrait them, getting them nice and crispy. All right, let's keep trying. Try Mr. Bean. Just disabled it. It did almost nothing to this photo. Oh, because it's disabled. Ah. Why didn't you use pull ID for this task? Oh, I mean, I didn't want to use SDXL. This is AnimateDiff. Nice. All right. We got enough portraits. Let's save this. And we'll go load up the default live portrait workflow from the thing so everybody has that. Cool. All right, 127. Load up a new tab in Comfy. AI Comfy one, custom nodes, live portrait, no, examples. And we're going to use the, oh, you know what? No, I'm not going to update. Video example. All right. So this is the one that comes with it. Go get it out of your folder. This is on your computer too. We are going to load up I have a video of me yammering, but don't I have a smaller one? Oh, I don't need a smaller one. Never mind. Yeah, it's this one. Oh, let me turn that on so you guys can hear it. I'm going to say some words. I'm going to move my face. You'll be able to hear that. Okay, so this is our driving video. And we are going to load our animation, which is in my idle folder. Yep. And we got some longs. Let's do... another long. We got this fella here. I'm going to say some... So he's idling. He's just idling. So hopefully me talking will take over his face. A couple things you need to change on the default workflow is video info. You actually want to get the frame rate from the source video. So image video info into there. The other thing is we actually want the audio from our source video as well. So we're going to plug audio into this node. Okay. So we're going to get our audio from this and we're going to get our video info from this. So it's going to get the source frame rate and the audio. Then when it slaps them together at the end, they'll be the right frame rate and the right audio. And I think you can just leave everything alone. This should work. And then this here determines how many frames of the video you want to load. So we're just going to start with 128 and try it out. Cool. I'll pull this up so you guys can see the... Hey, what's up? It's Purrs. I'm going to do some digital puppeteering. That's crazy. Hey, what's up? It's Purrs. I'm going to do some digital puppeteering. Worked even better than I thought it would. Let's do, I think it's like 550 or something. Forget how long this video is. Yeah, it's literally that easy. I mean, the way it is now, when you install LivePortrait, it should just work like this. You don't even have to do all that dependency whack-a-mole and swapping out versions and all that stuff. We don't like that. Okay. Keep going. Ooh, I don't like when you stop. Keep going. You can do it. Go. I need more RAM. I need more RAM, chat. I don't feel good about this. I think we're going to crash. I'm going to kill it. I'm gonna kill it. Oh, yeah. I mean, that's probably why right there. Hopefully this works. It's too huge. Okay, I swear I rendered a smaller version of this. Let me just check. Yeah. Look around. Talk mask. Hey, what's up? It's Purrs. I'm gonna do some digital. That's the one. All right. Copy path. Video. Oh wait, we gotta restart Comfy. Do 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 do. we're back. Okay, I'm going to load up the smaller version of this video. Sometimes helps to have a, smaller version of the video. Upscale doesn't help on the way in. Only helps on the way out. We're trying to load them into memory, so we want to load less. The other thing is I'm going to get rid of this frame load cap, and I'm actually going to take the frame count from here, make that the frame load cap of the destination video, and get rid of this and set this to 0. So it just loads, switch frame load cap back to an integer, into a widget, and set it to 0. So it'll load every frame. Then it'll tell this one how many frames it loaded and load that many frames of the subsequent video. And it should be more than enough because I looped this 12 times. So, yeah. And if you want to visualize these, grab this crop info node, pull it out, get a key points to image node. All right, grab that. Make yourself a video combine node. And this is going to be a little previewer. We're going to set it to 30 frames per second because that's all of our input footage. MP4, a low CRF of like 13 maybe. And we're not going to save the output because these are just viewers basically. We do that, we do that, we do this, and we do that. And then we can actually do the exact same thing here. Grab these two nodes, copy, Control C. And we want to see what this crop looks like as well. So let's pop one of those on here and then grab that crop info, plug it into this one. And then we have two little windows here where we can see exactly what our little tools are doing. And then you can use this same process here to find out what the cropped image looks like from this. And then we can also find out what the, there's another one, what this cropped image looks like. So we get all of our little previews in a little gallery. And it's kind of sick. All right, let's grab all these video combines, put them together. And then we can run it again and check all these results when we're done. Yes, but that only happens after the file is loaded in. My file is 2550 by 1200 or whatever, 1440. So the problem is that it's loading those frames into memory and then doing the upscale thing. So it doesn't matter about what happens after the upscale. We can't get the images into the buffer because I'm running out of VRAM while I'm streaming because the input source is too big. So you have to resize that stuff before it even hits Comfy. This is a Comfy bottleneck, not a, so this isn't something you can actually solve. Okay, so that should do the whole video. Oh, you guys can't hear that. I'm going to say some words. I'm going to move my face. I'm going to raise an eyebrow. I'm going to lower it. I'm going to raise the other one. I'm going to lower it. I'm going to smile. Be sad. And yeah, that's about it. Hopefully this works. Okay, so let's hit that again, and it should pop these into their little... Oh, I didn't plug audio into them. That's okay. We'll just use them as visualizers. So this helps us visualize what it's actually doing. The other thing we need is this one. And I need the cropped image from here. All right. And then we got our... So yeah, basically it is taking the face, mapping it out, stabilizing the footage and then replacing the footage with the new stabilized version of the source footage. It's actually really interesting to see all the steps sort of laid out like this. Just wait for it to crop my initial footage again. I don't know why it's doing it twice, but whatever. Okay. So we got me and my mask here. And then we've got Buddy in his mask. Key point. Yeah, there we go. Hopefully that makes sense. So like all this is being done by LivePortrait. Really, we just switch the input video. Upscaled. Idle. Words. I'm going to move my yeah, of course. Am I using the LivePortrait retargeting? No, I've played with it a bit, but no, not really. It's all just, you know, it works without it. So unless you need very specific stuff, yeah, I mean, go forth and play. It's nice because it's already done this. It shouldn't have to do it again. We'll just have to do the ones for, you know, new input footage. Nice. Didn't drop any frames either. 600 frames takes a minute, but it's still stupid fast. Because if you just use the image, the background doesn't move, man. And oh, wow. It's purrs. I'm going to do. Come on. Whoa, zoomed in so hard. Do some digital puppeteering. I'm going to say some words. I'm going to move my face. I'm going to raise an eyebrow. I'm going to lower it. I'm going to raise the other one. I'm going to lower it. I'm going to smile. Be sad. And yeah, that's about it. Hopefully this works. Hey, what's up? It's Purrs. I'm going to do some digital puppeteering. I'm going to say some words. Yeah, you probably want the footage to be backed off a little bit. So from, yeah, what I'm seeing is, you know, like maybe not quite so in close up, back off a bit. And then if you're, you know, in your input footage, if your background is moving because you're using the footage, the background's going to move too properly. So, and it'll make a perfect loop. So you can make longer loops. These are short loops I made for brevity's sake on the stream, right? So just make longer loops, increase the length of the frame count, and then, you know, maybe add some stuff to the prompt in the prefix about like swaying trees in the background or something. And then all the stuff behind the person is going to move around as they talk as well. So yeah, you can use this going forward. I'll probably package this workflow up and put it on the Patreon for the supporters, and drop it and all that stuff. But I mean, you can just watch the video and rebuild it. It's a pretty simple, you know, IP adapter setup with just that new clip vision enhancer. And then, yeah, you can just use it to literally prompt from your image. So yeah, have fun with it and enjoy it. And thanks everybody. And I'll see you all real soon. Been enjoying these sort of quick 1 hour deep dives into a little subject and then getting out. So hopefully I'll be doing a lot more of these more often. So thank you. See you guys all really soon. And check the YouTube and stuff, and like and subscribe and all the boring administrative stuff. And if you see my shorts and stuff popping around, give them a like and a share. I really appreciate it. It helps grow the channel a lot and get it onto some new eyes. So yeah, really appreciate you guys coming and hanging and dorking out with me. And as always, if you have questions, problems, hit up the Discord, join the help channel, talk about it, and send screenshots and all that stuff so that we can help you diagnose the problem. All right. Error messages, all that stuff. We like it. So yeah, Have a great night. Go touch grass. It's the weekend. I think I'm going to get off the computer myself too. All right. Have a great night, everybody. Thank you again.